Welcome again, dear grade 9 students, and let's continue the plane geometry that you need to know and the geometric properties that you have to remember. Now we are going to continue the properties of the right triangle. So after we mentioned the types of the right triangle that are the right isosceles triangle and the semi-equilateral triangle, we are now going to talk about the properties of these triangles. Let's start with the properties of the semi-equilateral triangle. First of all, let's recall what's a semi-equilateral triangle. It's a triangle, as you see here in the figure, whose angles are 90, 30, and 60, and here is the hypotenuse, which is the side facing the right angle as well. The first property of the semi-equilateral triangle is that the side facing 30 degrees, this side, as you see here in the figure, AC, is equal to the measurement of the hypotenuse divided by 2. So if the hypotenuse is 8, for example, then definitely this side is 4. If the hypotenuse is 7, for example, this side is 3.5. Let's make a little proof to let you understand where does this property come from. Let's start. Here is an equilateral triangle, as I mentioned previously, that the semi-equilateral triangle is the half of an equilateral triangle. Let's say that here the angle is 30 because we divide it into two equal halves. Then 60 is going to be divided into 30 and 30. Here, as I mentioned previously, will be a right angle, and here it is 60. Now suppose that this is the side of the equilateral triangle that's definitely equal to that side, which is the hypotenuse in this right triangle or in this semi-equilateral triangle. So this is the semi-equilateral triangle we are talking about. Its hypotenuse is definitely equal to the side of the equilateral triangle because three sides are equal. Now the side facing 30, as you see here, that one is divided is the big side of the equilateral triangle divided into two, because when I draw a median, there is a midpoint here, and thus this side facing 30 is definitely equal to half the side of the equilateral triangle, which is half of the hypotenuse as well. Now the side facing 60 is that one. Applying Pythagoras rule, we can deduce that when I have that this side is half of the hypotenuse and this is the hypotenuse, applying Pythagoras rule, we can deduce that the side facing 60 is equals to the hypotenuse times radical 3 over 2. So you can apply it later and make sure that the side facing 60 is equal to the hypotenuse times radical 3 over 2. So all what you have to know are these two properties. The side facing 30 is equal to the measurement of the hypotenuse over 2, and the side facing 60 is equal to the hypotenuse over 2. And here are examples to make things clear. Training exercises. Exercise 1. In this semi-equilateral triangle ABC, given that BC equals 8 and AB equals BC is equal to 8 only, we have to find AC and AB. So in a semi-equilateral triangle, it's enough to have one of the sides. We don't have to have two sides to get the third one. One side is enough to get the other two sides. So in this semi-equilateral triangle, suppose that the hypotenuse is 8. How to calculate AC and how to calculate AB? Let's look at AC. AC is the side facing 30. Notice here is 30. It's looking at AC. It's like an eye looking at AC. So AC is equal to the hypotenuse over 2, which is the measurement of BC, which is given 8 over 2, then it is 4. The reason is because it's the side facing 30. Now AB, here is AB, it is the side facing 60. Look, here is 60 and here is AB facing 60. Here is AB. So AB, applying the rule, is equal to hypotenuse radical 3 over 2, which is 8 times radical 3 over 2, which is 4 radical 3. If you are going to compare, the side facing 30 is 4 and the side facing 60 is equal to 4 radical 3, as if it's equal to that side multiplied by radical 3. That's to make sure that your answer is correct. You have to get the same value here, but multiplied by radical 3 for the side facing 60. Another exercise. Here is another figure for exercise 2. In this figure, suppose that AE equals 3. Surely AET is a semi-equilateral triangle. Here is the 30 degrees angle, here is the 60 degrees, and here is the right one. So where's the hypotenuse? The hypotenuse is 80. We have AE. So what do we have? We have the side facing 30. It's equal to 3. So AE, the side facing 30, is equal to 3. I have to calculate the hypotenuse AT, and then I'm going to calculate the side T. So let's think together. If the side facing 30 is 3, what about the hypotenuse? Let's think a little bit. What about the hypotenuse? If this one is 3, then the hypotenuse should be double of this one, because the side facing 30 is equal to half of the hypotenuse. Then conversely, the hypotenuse is double the side facing 30. And thus, the hypotenuse AT is going to be 2 times 3, which is 6. So, 3, we apply the rule. We write AE equals hypotenuse over 2. 3 equals AT over 2. Then AT equals 2 times 3, which is 6. What about TE? TE is equal, now TE is equal to the hypotenuse times radical 3 divided by 2. So TE is equal to hypotenuse times radical 3 divided by 2. If the hypotenuse is 6, as you see here, then it is 6 radical 3 over 2, which is 3 radical 3, because it's the side facing 60. So as I told you, always the side facing 60 is just equal to the same value of that facing 30 and multiplied by radical 3 in addition. Let's continue to see more examples. In the semi-equilateral triangle E80 again, given that TE is 6. Now, given that TE is 6, we are given the side facing 60. We have to calculate the hypotenuse AT and the side AE. So first of all, we have to maintain the hypotenuse all the time. So to calculate the hypotenuse, let's see and let's look at the given side. The given side is the side facing 60. So let's write the rule of the side facing 60. TE, this side facing 60, equals the hypotenuse times radical 3 over 2. Let's start evaluating. TE equals 6, as given here. The hypotenuse is the required, so it is 80. We evaluate it by 80. 80 is the required side, times radical 3 over 2. So we can now cross multiply to prove that, or to get that 80 times radical 3 equals 12, or 80 equals 6 times 2, which is 12, and divided by the number multiplied by it by radical 3. So again, 80 equals 6 times 2, and we divide by the number multiplied by it, so we will get 12 divided by radical 3. And you know from the real numbers chapter that whenever the denominator is a radical and irrational, we can rationalize it. We can make it rational by multiplying the numerator and the denominator by the same radical you see here. So by rationalizing, we are going to get that AT equals 12 radical 3 over radical 3 times radical 3 is 3. 12 by 3 is 4, then definitely AT, which is the hypotenuse, is 4 radical 3. So what about AE, which is the side facing 30? Let's see. AE is then half of the hypotenuse, which is 4 radical 3 over 2, which is definitely 2 radical 3. Now, on the same figure, suppose that TE equals radical 12. So again, TE, the side facing 60, suppose that it's equal to radical 12. Let's find again the hypotenuse AT and the side facing 30 AE. Again, we write the rule. TE is the side facing 60, so it's equal to the hypotenuse times radical 3 over 2. Radical 12, substituting the values, radical 12 equals 80, which is the hypotenuse, the required side, times radical 3 over 2. Radical 12 is 2 radical 3. So, again, we cross multiply radical 12 times 2, which is 2 radical 3 times 2, because radical 12 is 2 radical 3. So we get 2 times 2 radical 3 over the number multiplied by 80, which is radical 3. Simplifying radical 3 by radical 3, we get 4. So sometimes we get an irrational number, and sometimes we get a rational or a natural number. Okay, so if we get an irrational denominator, we have to rationalize, as you see here. If we get a natural number, then it's perfect. So let's continue. We got now that AT equals 4, so directly AE is gonna be its half, which is 2. So AE equals 2, which is half of the hypotenuse, because it's the side facing 30. So as you see here. Now we are going to talk about how to prove that a triangle is a semi-equilateral. Prove that its angles are 30, 60, 90. That's simple. So whenever you found that the angles are 30, 60, and 90, then the triangle is a semi-equilateral triangle. Another way, if the triangle is right and the shortest side is equal to half of the hypotenuse, then this triangle is a semi-equilateral triangle, and that short side is the side facing 30. Let's give a numerical example. For example, if you have a right triangle, surely it must be right, as you see here. So if you have a right triangle and the shortest side, suppose that the shortest side here, AC, is, for example, 5, and that BC is 10. You don't know anything about the angle, so you are not going to prove it a semi-equilateral using that idea. There is another idea to prove a semi-equilateral here. So we are not going to use angles. We are going to use the sides. It is a right triangle. The shortest side in this right triangle is AC. Suppose that AC equals 5 and BC is given 10. We notice that 5 is half of 10. Then that's the converse of the property of the side facing 30, that's equal to half of the hypotenuse, and thus this triangle is a semi-equilateral triangle, and the angle facing the short side is the 30 degrees, and the angle facing the other side is gonna be the 60 degrees angle. So again, whenever we see a right triangle and the shortest side in it is half of the hypotenuse, then this triangle is directly a semi-equilateral triangle. Another idea, for example here, another example. Suppose that AC is 4 and BC is 8, then directly we say that this 4 is the half of 8, and thus that side AC is half BC, then ABC is a semi-equilateral triangle and AC is the side facing 30. Also, if the triangle is right and the medium side, not the shortest one, is equal to the hypotenuse times radical 3 over 2, then this triangle is semi-equilateral. For example, if AB is equal to the hypotenuse times radical 3 over 2, suppose that, for example, BC equals 10, and that's equal to 5 radical 3, BA. So BC is 10 and BA is 5 radical 3. Then you notice that BA is equal to half of BC times radical 3, then this triangle is a semi-equilateral triangle, and that side AB is facing the angle which is 60. But this is rarely used. We mostly use this idea, which is the converse of the property that the side facing 30 is equal to half of the hypotenuse. Now, let's talk about the properties of the right isosceles triangle. As you remember, the right isosceles triangle is a right triangle that has two equal legs and two equal base angles. What are the properties of the right isosceles triangle? The most important property of the right isosceles triangle is that the hypotenuse, as you see here, is equal to the side, any one of these sides, because they are equal, times radical 2. For example, if AB is 3, then AC is 3. Then the hypotenuse is 3 times radical 2. Also, this can be proved using Pythagoras theorem. There is a proof for this using Pythagoras theorem. Let's continue. Examples and training exercises. In this right isosceles triangle, suppose that AB equals 4, then definitely AC is 4 too. We have to calculate BC. Directly you apply the rule, because BC is the hypotenuse, then BC is equal to side AB or AC whatever times radical 2, which is 4 radical 2. The reason written is hypotenuse of right isosceles triangle. Another example. In the right isosceles triangle here, given that BC is radical 8, so the given now is the hypotenuse and we need to find the side. Again, the difference between this exercise and this one, the given here is this side and we need to find the hypotenuse, while the given here is the hypotenuse and we need to find this side. Again, we write the same rule. The hypotenuse is equal to this side times radical 2. That's the hypotenuse of the right isosceles triangle. So, what about the side? How to calculate the side? Just evaluate. BC equals radical 8, which is AC times radical 2. Then AC equals radical 8 divided by radical 2. So, we divide by this radical 2 to get AC, which is 2 radical 2 by radical 2, which is definitely 2.